Hello, and welcome to Astronomy 100. In this last video related to galaxies, what we're going to do is concentrate on understanding what we call the large-scale structure of the universe. And what that simply means is that if we could back out and see a really wide angle, the biggest view of the universe itself, what would the structure of the universe look like? Is it gatherings of objects? Are they equally spaced in between? Is there some sort of order, or is it just chaotic? And so that is really how we're going to wrap up this topic of the galaxies, and it's kind of a nice way to put it finally to rest. So let's go ahead and get started. Now, this first picture here, again, is our splash screen that we've been using, but again, I want to start with this one because as we've been talking about in previous videos, you can see that our universe is really one that is filled with galaxies. In the previous couple of videos, we talked about how it took a bit of effort for us to realize that the universe is one filled with galaxies, as opposed to the Milky Way galaxy being the entire universe. And if you recall, it was the Shapley-Curtis debate that was able to put to bed, or at least start us down the road to put to bed the concept of whether it's a universe full of galaxies or just one galaxy. Now, in another video, we talked about morphology, which is, of course, the shapes and the sizes of the galaxies themselves. But in this one, what I want to concentrate on is really how the universe is structured. And the way that we're going to do that is we're going to start fairly close to home, and we're going to work our way steadily outward until we eventually get to get the idea of the entire universe in one single view. Now, I'm going to start with this illustration here. And if you recall, the Milky Way is our galaxy, and that our galaxy is a spiral galaxy. It's technically a barred spiral galaxy. Recent information over the last 20 years has shown us that it is not only a spiral, but it indeed is a barred spiral galaxy. And if we could look at where our location is within the galaxy itself, what we would have is, of course, many, many stars, lots of gas, lots of dust, and our location, the solar system, the sun with the planets going around it, the sun is located right here at the center of this illustration. And for scale, this white line is about 1,000 light years across. Now, I'm going to bring up some words to help us understand some of the details. Again, the location of the sun is right here. And what you'll notice is that there are some familiar objects that are shown for a comparison when it comes to distances and location. The very famous star called Betelgeuse would be right here. The belt of Orion, the 3 stars that we see that make up the belt, would be over here. And again, you can see some other objects that are relatively nearby objects. Notice that the arms that spiral out from the center of the Milky Way galaxy, you can actually see that they do have names: the Sagittarius arm, the Orion arm, the Perseus arm. And technically, our location within the Milky Way galaxy is just inside of the Orion arm that is our home there. Now, we're going to, of course, get a little bit further out, switch to the next one here. So remember, the Milky Way galaxy, if we had the ability to look at it from the outside, would look like this. Notice it is a barred spiral galaxy, and the Milky Way has a size of about 100,000 light years all the way across. And remember that the sun's location is about 2/3 of the way out, so we're about 28,000 light years or so from the center of the Milky Way galaxy. And if you recall, surrounding the Milky Way galaxy is what we call the halo to the galaxy. And the halo is the home to all the globular clusters. And each of these little white dots represents a cluster of stars called, again, a globular cluster. Each of these globular clusters might have anywhere from 100,000 stars up to several million stars. And the Milky Way has about 150 of these globular clusters that swarm around it, above it, and below it, creating, again, the halo of the galaxy. And if you recall from a previous video, that these stars in these globular clusters are actually very, very old. These are what we call population 2 stars, which are the first generation of stars, the oldest stars in the universe. So let's get a little bit further out. Now here, of course, we have the Milky Way once again, but now we're starting to get far enough away that we can start to see some of the neighboring galaxies. So the Milky Way is not alone in the universe. The Milky Way is just one galaxy amongst many, many other galaxies that are part of the universe itself. Notice our scale is quite a bit bigger. This green line now is about 100,000 light years in size. So again, the size of the Milky Way, about 100,000 light years. The Milky Way galaxy has several nearby neighbors. One in particular is fairly close, but we can't see it from the northern hemisphere. And if you recall in a previous video, there are two other galaxies called the Magellanic Clouds that are also neighbors to the Milky Way, the Large Magellanic and of course the Small Magellanic. Let me bring up some details here. So LMC, SMC. The Sagittarius Dwarf is, as far as we can tell, the closest neighboring galaxy to the Milky Way. So we have a neighbor very, very close, very nearby, if you will. Now, again, some of these are other galaxies that are nearby. The names are related essentially mostly to the constellations that you have to look through to see these galaxies. So an example is the Ursa Major Dwarf is a dwarf galaxy that you have to see in the constellation of Ursa Major. Now let's get a little bit further out. And the grouping that we just saw in that last illustration is now all of this right here. And we actually have an official name for our neighborhood. It's not a very imaginative name, but it is called the local group. So the local group is the name of all the galaxies that are with the Milky Way that are part of our neighborhood. It almost sounds like a gang name, or trust me, there is no gang sign that go with it. Now there is another neighborhood nearby, that's right here, and this is the Andromeda Galaxy. So the Andromeda Galaxy is also a spiral galaxy, very similar to the Milky Way, but it is about 2.5 million light years distant, and it also is accompanied by some smaller galaxies that make up its neighborhood. So we share space in our universe with one other very, very large galaxy nearby. Now, because the Andromeda Galaxy is actually a more massive galaxy than the Milky Way, it is actually gravitationally pulling the Milky Way towards it. So all of these galaxies as a cluster are actually moving towards the Andromeda Galaxy. And just interesting to note, in about 5 billion years, the Milky Way will merge with the Andromeda Galaxy. So this is our neighborhood called the local group. It is a cluster of galaxies, meaning a grouping of galaxies. Now, let's get a little bit further out. Of course, here are some of the names, of course, before we do that. And you can see that these are just all names that are cataloged names for these galaxies. It's not significant to know those names, but again, the important thing is the Andromeda Galaxy nearby. Let's get a little bit further out. And there's a word that I want to introduce. It gets a little bit silly at this point. The word is supercluster. And what a supercluster simply is a cluster of clusters. I know that sounds weird, but you can have a cluster of galaxies, but what we have discovered is that those clusters themselves create groups. So a supercluster is a cluster of clusters of galaxies. And the one that the Milky Way belongs to is called the local supercluster. Notice the scale. This green bar up here is 10 million light years across. So we're getting quite large, getting a very big look at the universe. Notice that you can see that there are groupings of galaxies. In this case, every single white dot that you see is a galaxy, and you can see that the galaxies group together. But notice that this is a cluster, this is a cluster maybe, and this is a cluster here, and notice that they themselves create a grouping. So a supercluster is a cluster of clusters of galaxies. Here are some of the details here. Again, just to show you, here's the local group. That's the one that the Milky Way belongs to. And it turns out that we are very, very close to the Virgo supercluster of galaxies. That is a very, very large gathering of galaxies that you could actually see in the sky. If you had a telescope, you could see all of the galaxies that go with it. So the Virgo cluster, which makes up, of course, what we entirely call this as the Virgo supercluster. So the Milky Way is part of the local group. The local group is part of the Virgo supercluster, which is mostly populated by the Virgo cluster of galaxies. So let's get a little bit further out. Now, again, every single white dot that you see is a galaxy. And notice how, indeed, the clusters of galaxies do indeed cluster themselves. So it's a silly name, but it's an appropriate one. Notice you start to see structure. You start to see what we call filamentary structure, filaments of galaxies. The galaxies don't seem to be evenly distributed throughout the universe. They seem to group together. And then there are big places where there are no galaxies, surrounded by places where the galaxies gather together. And sometimes this structure is referred to as soapy or foamy. And what we mean by that is if you've ever seen foam or soap bubbles, the idea is that when you have like a sponge, that is where you have lots and lots of holes surrounded by voids that are surrounded by material, or bubbles where you have big gaps in between the bubbles, or you have the material surrounding emptiness. It is sort of like that way. If you've ever had some sort of foam that eventually dries over time, the pattern that it leaves on the surface looks very much like this. Notice the scale now is 100 million light years, which is the size of this green bar here. And then, of course, some details to go with this as well. So these are now all superclusters. Each of these is a supercluster. And, of course, ours that we belong to is the Virgo supercluster. Now, if we were to try to show you how we know this, it's a little complicated, but let me give you the idea here. This is an actual measured map of our universe, and the way that this works is that we have telescopes who are dedicated to measuring the distances and the locations of galaxies. So what happens is the astronomer will make measurements of galaxies that'll help him or her know the distance to the galaxy, and then they know where the galaxy is located in the sky. Now, when you put those two things together, you get a three-dimensional map of what our local neighborhood would look like. And again, every little white speck on here is a galaxy. So these are actual measurements. We look deep into the universe, we map all the galaxies along each line of sight, and then when we put all the lines of sight together, we get this image here. Now, the reason why there's a gap right here and a gap right here is because inside of the Milky Way, we have a difficult time seeing through the Milky Way along the long axis of the disk. We can't see through the gas and the dust, but we can see quite readily out of the Milky Way. So this is looking out of the Milky Way up, and this is looking out of the Milky Way down, and we can obviously map the galaxies quite well. We just have a hard time seeing through the clutter of the Milky Way itself. Now, I want to show you a video. This was used by, a supercomputer was used to create this video, and it's just only 25 seconds long, but what it's going to show you is a journey through this three-dimensional structure that makes up the universe itself. And of course, I'll talk to you as we go through it. Let's go ahead and start that now. So this is, again, just traveling into the structure of our universe. What you are looking at is many, many different galaxies, but notice how they're gathered together in these long filaments or groupings, these clusters, and of course these superclusters. If you could travel through the universe, and you could do it really, really fast, you would be able to travel through it and see it in such a manner here. Now, this is much faster than the speed of light, and of course it comes back to home there. It's kind of an interesting video. Now, the last thing I want to do is show you an image that is produced by a computer. And this is showing you the large-scale structure of the universe. Now, this is not data, meaning these are not plotted or measured galaxies, but this is a computer that is simulating the structure of the universe if you could see it on a really big scale. Every little tiny white dot in here is a galaxy. And so notice the groupings of the galaxies. Again, notice the foamy or soapy filamentary structure of it. If you could step way, way back and see the universe, this is the structure that the universe would have. We have lots of galaxies gathered together in groups surrounding big voids where there doesn't seem to be galaxies, and it really has this overall structure on the largest possible scale. Now, I'm going to take us back home. Watch how I'm going to do this. So we're going to say that, let's say that this part of this image here, or this illustration, is containing all of the local clusters of galaxies nearby. So in other words, all of this right here expands out to this. And then getting a little bit closer to home, let's just back up, let's back down to home. And so this is now the neighborhood of galaxies that make up the local group, and you can see that right here. And then, of course, if we could zoom in a little bit closer here, we have our neighboring galaxies and, of course, the Milky Way, which would be at the center of this. And then, of course, the Milky Way galaxy itself would be this galaxy here, barred spiral, and you are located right there. So the sun, again, is about 2/3 of the way out. So what's nice is astronomy has allowed us now, through measurements, to be able to know the distances to very, very far away galaxies. And by creating maps of the universe, we can see the overall structure to it. And that is our current understanding of the large-scale structure of the universe. So that concludes our discussion on galaxies, and I hope you've enjoyed it.